Hi, everybody. Today I am going to be talking to you about our latest internal PromptQL agent, which is our sales agent. So I'll start with an app overview. In our app, we have 4 connectors. There's 2 Salesforce connectors, one for tables and one for views, and they both connect to BigQuery, which contains ETL'd Salesforce data. We also have a Postgres connector that connects to a database containing ETL'd Clari Copilot calls. With embeddings, we're storing using pgvector. Lastly, we have a functions connector that allows us to perform semantic search over our Clari calls. Let's see what kinds of things we can ask PromptQL about Salesforce. The PromptQL agent has access to the schema and relationships along with field annotations, so it understands the data sources it is connected to. If we ask which account has generated the most revenue, PromptQL will write some Python code to query the data and calculate an answer. Since this is our live sales agent, there's some data we've had to redact to maintain our customers' privacy. The agent queries the data and identifies which customer has generated the most revenue and breaks down where the revenue comes from, whether new business, renewals, or expansions. The most important part of the PromptQL process is the query planning. Notice how the agent will make a plan before it retrieves the data and constructs an answer. This yields massive improvements compared to using an LLM alone. We can ask lots of different questions to PromptQL. In the stored memory artifacts, we can see the retrieved data and even download it as a CSV or JSON file. PromptQL can identify the largest opportunities from our Salesforce data and tell us what stage they're in and other information like their expected close date. Notice how the query gets planned and lays out multiple steps before retrieving the data. The plan lays out which tables and fields to query, how to perform filtering, and how to sort the data. The next thing I want to show is how we use the Clari Copilot connector to ask questions about our sales call data. Before we jump into the examples, though, I wanted to show a bit of code to explain what's happening behind the scenes. Whenever a new sales call occurs, we have background workers set up to ETL the call into our database and create embeddings that allow us to perform a cosine similarity search. We expose the ability to do a semantic search using functions. We annotate these functions with detailed information about what the functions can be used for and how PromptQL can call them. We've also set up relationships telling PromptQL that it can perform a join on the function response to the calls table to pull in additional call information. Under the hood, all that's really happening is a SQL query that utilizes pgvector to do the semantic search. So let's see some examples. The semantic search over Clari calls is really exciting and powerful. When I ask a question like tell me calls discussing Postgres, PromptQL can do a semantic search across calls to get the most likely to have discussions involving Postgres. Notice in the query plan how the agent specifies that it will use the semantic search calls by transcript function. It's thanks to this query plan that we're able to achieve this high level of accuracy. It's pretty cool, and I want to show some other examples that'll really demonstrate the value of this kind of tool. Imagine if you could ask questions like, in that call last week with ABC Core, who did we say needed to finalize the technical content? And have PromptQL look over the transcripts and give you an answer. Notice how the constructed query plan explains what the agent plans to do before it does it, similar to how chain of thought works. You can even use PromptQL to ask about PromptQL. In this case, we'll ask about any sales calls where PromptQL is mentioned. The agent is able to use semantic search to identify calls that mention PromptQL and summarize and provide details on the calls. We're focusing on the query plan again here, since that's the most important of the PromptQL agent. The answers PromptQL gives are accurate, but the focus is on the plan because that's what is allowing it to give those accurate answers. And I hope that if you take anything away from this, it should be that it's thanks to the query planning that PromptQL is able to achieve state-of-the-art accuracy and repeatability. You can try out PromptQL today, so connect and talk to your data and let us know how you're using PromptQL. And that's what I had for you today, folks. So I think that is just about everything. If Rob, you want to come back on?
I'm back. Yeah, thanks, Tristan. That was great. One thing I want to talk about from your demo that you just did more than anything is that we've got data coming from different sources, right? And we're combining it together under this super graph kind of umbrella that we have. And while we're talking about PromptQL, really the underlying technology that's enabling all this to happen is Hasura DDN, right? It's that data delivery network that's a single semantic data layer that's bringing everything together. Could you just talk a little bit about kind of the power of being able to bring in these disparate sources and then ask questions on that data?
Yeah, I think it's it's funny because being here at Hasura, it's easy for us to forget the power of Hasura because we're so used to using it all day and every day, and we've got this DDN, and it's for most people it's a shiny new thing, but for us it's kind of already like, oh, well, I've been using that, but it really is so powerful because it lets you bring in pretty much anything, right? Like especially now with like our DuckDB connector and everything, it's like it doesn't matter. You've got Parquet files in some bucket somewhere, pull them in. You've got Postgres, you've got Mongo, you've got a vector database, whatever it is, you can bring it in. And not only can you bring it in, but you can set up relationships. It basically solves the data loader problem, right? Where let's say I have something in one database and it's got an ID, and then I have something in another database that has that same ID, and maybe it's a vector, or maybe it's an AI inference model, or something where I can't keep them in the same database, right? Now I can take those and I can say, okay, well, that's fine. I've got one in this database, one in this database, but there is a relationship there, right? And I can tell DDN, hey, there's a relationship. And then PromptQL can look at that and say, oh, cool, well, I'll just take care of data loader for you. You don't have to worry about it. You don't have to do all the fancy joins. You don't have to worry about performance. I'll push it all down. I'll take care of it all for you. I'll give you optimized, efficient queries. And where we have to go to different data sources, I'll batch it for you efficiently. And so, it's almost like giving PromptQL this like power tool where we're saying, hey, we're going to give you the best query layer in the world to access your data. And so, when you talk about empowerment, right, like you look at our solution versus other folks, and it's like, well, we kind of have a little bit of like home court advantage in a sense when it comes to accessing data, I would say. So I don't know. That's my thoughts on that, Rob.
Yeah, 100%. And what I was driving at, right, is that ability to traverse kind of all these disparate data structures together into one unified graph and giving PromptQL access to that is a great thing.